That's right, we are going to get wound up and crazy on some arrays, one-dimensional arrays. That explains why I got the 1D right over here. So let's go ahead and get started. Oh, you know what? Somebody asked me a question the other day on a comment. They're like, who's this dog? Okay, that's my dog, Rowdy. I don't know if I mentioned it or not, but that's Rowdy, and Rowdy's my dog. Okay, he's 9 years old at this point in time in the video, known for quite a while. He does one trick. The only trick he does is he can sleep standing up with his head on a coffee table, so it's pretty amazing. But we're not here to talk about Rowdy. We're here to talk about arrays. This video is going to attempt to keep it somewhat simple. Arrays can get very complex, as probably anything you've noticed with programming. So this is an introductory level. If you're really good at arrays, you might want to move on to another one of our videos a little bit more complex than this. However, if you're new to arrays or you need a refresher, or you're not quite sure what's going on with arrays, we'll give you the basics on arrays right now. Arrays are a data structure that's used to store lists of information or objects. So array is just basically something that just stores a lot of information. If you have a cell phone, you probably have arrays on your phone. Say your contacts, you have an array of contacts, okay? Those contacts are all objects inside your phone, at least with modern day phones, because those contacts, it will have the person's name, their phone number, probably their email address, maybe their social media accounts, where they work, some other information, okay? So that object has a lot of information. An array would store all that, okay? Now that's not exactly a great example of array, and you'll see why once we get into array list and two-dimensional arrays, but nonetheless, just to keep it kind of simple, it's a list of information. Another thing you can think of is like in video games. Say if you ever play a game called Fortnite, you have, let's say one of the backpack options, you have like up to 6 objects you can keep within there. Only 6, okay? That'd be a good example of array.
Talking about arrays.
Because you have a limited size of slots that you can store information. And that information you're storing happens to be different kind of objects that you would use in the game. I would show you some Fortnite on here, but we're here to learn about Java. And Java's not made, or excuse me, Fortnite is not made with Java. Minecraft is, but not Fortnite. I think it's C++. I'm pretty sure it is. Okay, all elements in the array have to be of the exact same type. And if you are a professional programmer and you're getting ready to send me a comment explaining that I shouldn't have capitalized integers and doubles and booleans, okay, I know that, but I just went ahead and rolled with it. If you don't know what I'm talking about, just keep on smiling, and here we go. So these are the kind of different element types that you can store within an array. You can put integers, some of the double numerical values, strings, booleans, and then any other type of objects. You can also put float values. Any of the other type of primitive data types you have can all be stored within arrays.
Arrays store list of information,
as well as any particular type of object. If you think of the phone example I gave, let's say you have 100 slots in your phone that can store 100 contacts. That would be 100 objects that your phone could store within that array. And over here is an example. I have an array called friend names, and these are some of my friends I have in my phone, or my friend names array. I have my friend Cochise, Samson, Optimus, Amelia Bedelia, Rowdy, and Pepper. And Pepper is Rowdy's sister. Okay, so that's the other dog in my house. But I don't have pictures of Pepper. She's not as photogenic as Rowdy. Okay, Rowdy has a gigantic head. Anyhow, back to friend names. So these names are all stored within positions. There are 6 total. However, when we start off with arrays, we start counting them with the number 0. Okay, so the first position, or the first, location position or index of the first item in an array will start at 0 and it'll go all the way up. So if you have 6, just know that you subtract 1 from the last number, and that tells you the last index position for that particular item. All right, okay, clear as mud. Next one right here, array elements. These elements, or excuse me, each item is stored in an array is called an element. So all these items are stored elements. You'll notice I changed the way it looked over here, okay? It's the same list, Here I just kind of kept it in a type of syntax that you might recognize just from typing up Word documents. Over here I put it into a more program-centric styled writing where we use these little square braces to keep the number in between them to represent the subscript or the index position of these particular items. Okay, so when we write our programs, we're going to keep the array numbers within these little square braces right here. So each item stored in arrays is called an element, and the subscripts are the index values. You can call them index values, subscripts. I've heard a couple other names, but just know we'll use these terms interchangeably. And like I told you, it says subscripts are listed as 0 to n minus 1. N is the last number subtracted 1, and that's the value. For example, we have 6 total positions, and 6 would represent n. Subtract 1 from 6, which is n, and it gives you 5, and that's why pepper right here is stored at the 5 position. Okay, technically it's the 6th index or 6th subscript position within the array, but it's the number 5 represented right there. You'll get used to this, especially when you spend a lot of time typing up code and it doesn't work and you can't figure out why. All right, how to initialize arrays. Okay, arrays are a little bit different than what you've seen, but they're not too terrible. They're actually kind of easy to implement. So you're going to need the square braces to create and use an array, which I just talked about. And here's some different examples. Let's say I'm creating an array called scores, and this scores array is going to keep all the different scores of different players throughout the game. It's just going to keep the number value, not their names, just the number value, okay? This is 3 different ways right here to do the, or excuse me, 3 different ways to do the same exact thing, okay? Each one of these creates an array called scores that has 100 index positions within it, okay? Each one of these is exactly the same. The difference is I put the square brace before the variable name right here. Here I put the square brace after the name. And down here, oh, you know what? I made a mistake. Boop. Okay, forgot my semicolon. Right here I put the scores. I declared the array right here, but then I assigned the value here on another line. Okay, so you can declare the array, but then later on in the code, you can assign it later. And I just put it right after just because we're doing a presentation. You'll see here later on when we do our practice example that it doesn't necessarily have to be right beside each other. But it does have to be assigned before you start using it because Java doesn't like that. Next example, reassignment. Okay, the thing about arrays is arrays. Roar. Once you create them, they're pretty much set in a digital stone. However, you can take the same array name and give it basically make it a new array. Okay, and let me use my imagination to think of an example here. But before that, here's the example I typed up. So we create an array called money. It stores double values. And this could have been string, booleans, floats, integers, longs, or whatever. Okay, so this money variable, or excuse me, money array variable has 10 positions. However, let's say later on in my code, I'm like, I still want to use the money array, but it needs to be a lot bigger. Okay, so what I'll do is I'll recreate it with this word right here, new. Okay, notice I use new up here. We have to use new all the time. Okay, and I'll explain why in a minute. Okay, so we have to create a new money array. We use the same variable name, except we're going to recreate it for up to 33 positions. Now, what happens to all the information that was stored in there before? Well, that gets deleted, essentially. However, there's ways to store it that you can reassign it back to the new array. So it's not really that much of an issue. If you're doing something like this, then you probably already have a strategy in place on how to handle that transfer of data back and forth. Okay, so not a big game changer unless you accidentally did something like that. Okay, so since arrays are objects, we have to keep using the word new. So if you read that while I was talking about the word new, that explains why. So an array is an object, so we have to use the word new. Much like how we constructed objects in some of our previous examples where we'd say new carnivore class constructor, assign the value or assign the all the information to the particular variable that we're using to store that. Let's see right here. Array sizes cannot be changed after they're created. I already talked about that. And I just said that. But a new array can be assigned to an array named 1. Okay, what did I mean by that? Well, what I meant was, I'm not quite sure my terminology there, but we can reassign the variable a new array. Okay, that's basically what I'm talking about. And let's see, arrays default values. Whenever you create an array, you don't have to necessarily give it values. We'll go through all that in a second. But your integers, doubles, and floats are all set to 0. Booleans are all set to false. Strings are all set to null, which means it's empty. And objects are set to null as well, which means they're empty as well. Okay, they are only set if you do not assign values when initializing the initializing the values. Okay, so whenever you create your array, let's say right back here in this example, we created a scores array. Okay, so this scores, it had 100 positions that are all set to 0, okay, because we did not assign any values to those. Next, assigning values to your arrays. This is the kind of easy way. This is the way you'll think of when you first start looking at arrays. You're like, oh, this isn't so bad. And then we'll make it really difficult. So we have an array called names, and we give it 3 positions, 0 to 2. Remember, n-1, so 3 minus 1 means the last index position is 2. And then right here, whoa, what did I do with this? I should have put 4. I had an error right there. Okay, so let's say we have 4. Okay, so we go from 0 to 3, and I assign each one of these index positions a new value. Okay, so what's happening is the names array at the 0 position gets assigned the name Cochise right here. Okay, this names at the 1 position gets the name Samson assigned to it, and then names 2 gets assigned Optimus, then names at the 3 position gets Amelia Bedelia right there. Okay, and that's one way to manually assign all the values. You could hard code the values into each one of these index positions in an array. Down here, money array, which we could have done this names array exactly like this with string values, but I'm just showing you a different way. We put the values inside a curly brace right here, and then it automatically assigns it. Now with the money array, we don't have to tell it how many positions to have, because Java, it's pretty smart. It knows that we have 3 values right here, and it's automatically going to create the money array to store 3 values for it. Okay, now this is really good and the easy way to do it if you're dealing with small values. Okay, when you start getting to large programs, you'll be dealing with 100, 200, 1,000. I mean, who knows how many you're going to have. So the moral of the story, just remember, this is good for small arrays. Next, an important error you're going to need to know about is called array index out of bounds exception. This is going to be caused when you put in a negative subscript into your array. For example, if you look over here on my code, the ninja, which is at -1 in honor of our ninja gamer friend out there, okay, is at a -1 position on the array index, so that's going to cause an array index out of bounds exception. The other side of the story is that when we have a subscript that's greater than the higher index out of bounds position, for example, El Patron 222 or 222 is at the 6th position, okay? So this would cause an array index out of bounds exception. The only thing that wouldn't would be anything from 0 to 5, which is what we created originally for the friend's name array. So if we put something as -1, causes errors. We put something beyond the 5th position, or excuse me, the array index 5, which is technically the 6th position, and this would be the 7th position. If we put anything there, then it will cause that error. And the error will show up in the console of your IDE, and it's kind of a ubiquitous term. So it's something good to know, because if you see that name pop up, you know that you did one of 2 things. Next, we're going to look at a couple different ways to traverse arrays. Traverse arrays means essentially how to get through all the information in the array so that way you can access it. For example, we have an array called myInts. What we want to do is we want to be able to print it out on the screen. And it has 4 values, so it's an array length of 4. Oh, I forgot to mention this happy little guy right here. So array.length, that returns the length of the array. So you put the name of the array right there, dot length. Okay, there's no parentheses behind it like in the string objects. You just put the word length behind it, and what it does is it automatically tells the computer how long the array is. However, that could be kind of tricky if you're dealing with a situation like this. So right here we have an integer array called myInts. It has 4 values, 0, 0, 11, 22, and 33. Okay, you should probably be able to guess what index position each one of these are. And right here in the for loop, we're going to declare the integer I at 0, and we're going to say as long as I is less than or equal myInts.length minus 1, we're going to keep adding to it. And down here, we're going to go and print out each of the different array positions starting at I, which will be 0 for the first one, and we'll print that out on the screen. And it's going to do that through the entire length of the array. And you can see it right here when it prints out the results. So at I0, it's going to have 0, 0 there. Okay, I just chose the same numbers as the position to kind of help you map it out in your mind. Once it goes through the array, it adds 1 to it, so now I is now 1. And next time, it's going to say myInts at the 1 position. It's going to print out 11. Then it's going to go back through. It's going to add 1 to the I, which makes it 2. Then it's going to print out the myInt at the 2 index, which is 22. And then it'll do the same thing with 33 by adding 1 to I, which makes it 3. And you can do that for the entire length of the array. Now the key is make sure you have the variable.length minus 1. If I did not have minus 1 right here, it's going to cause an error in the program, because think about this. All right, think of our array index out of bounds exception. myInts.length is returning a value of what? It's returning a value of 4, right? Okay, because there's 4 positions in here. However, 33, which is the last one, is at the 3rd position. Remember, this is 0 position, 1 position, 2 position, 3 position. Okay, so if this returns a value of 4, okay, this is going to cause an array index out of bounds exception because you have tried to access a particular piece of code that does not exist in the array. Okay, next, my favorite, the for each loop. This is a lot of fun. We'll use these quite a bit in Unity whenever you see those tutorials. So we're going to create another array variable called myInts, and we're going to assign it 4 values just like before. And down here we're going to put a 4, and this is a for each loop. What we do is we just give a variable name here. Okay, you can call it anything you want. I'm calling it tempInt. I could call it rowdy if I wanted to, but it's probably not a very accurate name. And this little colon right here is telling the computer that we're going to create a variable that's going to cycle through, beginning with 0, the entire length of this array. And we're going to print it out down here on the screen. So whenever the computer starts, it's going to start at the 0 position, and tempInt gets that value from the 0 position, which is 0, 0. It prints it out, and the computer knows that there's more values in here, so it's going to keep doing this over and over again. So it's going to come back and say, okay, tempInt is now 1 of this array, print it out. Tempint's now at the 2 position of this array, print it out, and then it's at the 3rd position of this array, print it out. And that's why it gives you the same exact results as this one right here. Okay, and the good thing about this one is you don't have to worry about accidentally forgetting the -1 on the myInts.length minus 1. Okay, which one's better? It's really hard to say. Some people are probably very good at using one over the other, or it just really depends on the situation. What's important though for this and the AP test is that you know the difference between the two, and you know how to use both of those, and it's going to help you out in the long run with all the code. Okay, we're going to end the video right now because it's getting a little too long for my taste, and we'll start jumping into the project for this particular section in the part 2 and other videos. All right, my name is Ryan. Thanks for watching, and make sure you just smash that subscribe button and smash it till it just doesn't work anymore. All right, I appreciate it, and we'll see you in the next video.